Hi, welcome to this session on the second part of redox reactions, which is calculating oxidation numbers. We have already defined a redox reaction based on the loss or gain of oxygen, hydrogen, and electrons. Whenever we have a ionic compound, say like magnesium oxide, it becomes very easy for us to track the movement of electrons, because here magnesium would always give two electrons because magnesium is in the second group in the periodic table and oxygen takes the electrons. But if we have a compound like sulfur dioxide, then the calculation becomes slightly difficult. Though we know that sulfur is giving the electrons and oxygen is taking the electrons, with slight difficulty we can very well get to know how many electrons are being given and taken by sulfur and oxygen respectively. But imagine we have sodium hypochlorite. Now if we have a compound made up of three elements, in such a case the movement of electrons is very difficult to keep a track. To overcome this difficulty, we have the concept of oxidation numbers. One thing to remember is that in chemistry, the oxidation number and the oxidation states are used interchangeably. So basically, oxidation number or oxidation state would mean the same to define and tell us how many electrons can be lost or gained by an atom. To determine the oxidation number, we have a set of rules to be followed. The rules helps to clearly define the oxidation state of an atom in a compound. Let us look at those rules now. Always the oxidation number of an uncombined element is 0. It is 0 because there are no gain of electrons or loss of an electron in an uncombined element. And similarly, if we are talking about a neutral compound, even then we see that the sum of the oxidation numbers of all the elements making up the compound is 0. But if we are talking about an ion, then we see that the sum of the oxidation numbers of all the elements in an ion will not be 0, but it will be equal to the charge on the ion. Always the most electronegative element in a substance is given the negative oxidation number, and that's the reason why always the oxidation number of fluorine is -1. That is because fluorine is the most electronegative element in the periodic table. The oxidation number of hydrogen is always +1, but however there is one exception here. If hydrogen is binding to a less electronegative element, then the value of the oxidation number of hydrogen becomes -1. Similarly, we have the oxidation number of oxygen, which is always -2. But when we are discussing about peroxides, then the oxidation number of oxygen is -1. But when it is combining with fluorine, because fluorine is more electronegative than oxygen, we see that oxygen gets a positive value. To understand the concepts better, let's take up few examples. Let's take the example of sodium chloride. Sodium is always having a value of +1. Why is it always +1? Because it has only one electron to donate, because it is in the first group of the periodic table. And we know very well that sodium chloride will have an oxidation state of 0 because sodium chloride is neutral. Therefore, for chlorine, we see the oxidation state to be -1 because you see sodium chloride, Na taking +1 and NaCl as such should take 0. So if this is -1, we see that the overall the sum of oxidation states would be 0. Now let us do one thing. We will take the example of sodium hypochlorite, which has a formula of NaClO, and try to find out the oxidation state of chlorine here. Again, we know very well that sodium has an oxidation state of +1. Oxygen has an oxidation state of -2. And as a compound, we see that sodium hypochlorite is neutral, and so it has to have an oxidation number of 0. So if we need to find out the oxidation state of Cl in the compound, we see that chlorine gets a value of +1. So we have NaClO. Na is +1, O is -2, whose sum should be 0. So Cl gets a value of +1 because we see that these two would add up to 2, +2 and -2 would give us a sum of 0. Let's go to the next example, which is NaClO3, which is sodium chlorate. And let us try to find out the oxidation state of chlorine here. Again, let's write it down. Sodium will have +1 oxidation state, and oxygen here would be again -2. So if I call chlorines to be X, I get a value something like this. So I have sodium having +1 plus chlorine, we will call it as X as of now, and oxygen is -2, so it becomes 3 into -2, which should be giving rise to 0. So therefore we have X is equal to +5. So you can see that in these three examples, oxidation state of -1, +1 and +5. So the oxidation states of a particular element can keep changing except for oxygen, hydrogen, fluorine and the compound as such, right? Let us take few more examples to make the concept quite clear. Let's take the example of NH3, which is ammonia. Nitrogen is more electronegative than hydrogen. Therefore, hydrogen will have an oxidation state of +1. And ammonia is a neutral molecule. So here we will have, if we designate the oxidation state of nitrogen as X, X plus 3 into +1 would be 0. So nitrogen would have an oxidation state of -3. Similarly, if we take an ion as an example, which is NO2 minus, and we need to find out the oxidation state of nitrogen, let's call the oxidation state of nitrogen to be X again here, and oxygen is always 2, so we have 2 oxygen atoms here, so it would be 2 into -2, but here it is not 0 because this has a charge of -1 here, so this should give rise to -1. And if we calculate the value of X, we see that in this case the value of X would be +3. So here in an NO2 minus ion, the oxidation state of nitrogen would be +3. Let's take one more example of NO3 minus. Now in NO3 minus, let's try to see what is the oxidation state of nitrogen. We have X plus, we have 3 atoms of oxygen into -2 having 1 negative charge on the ion. So solving for X, we get X is equal to +5, and you see here that the oxidation state of nitrogen would be +5. So you see that the oxidation states of a molecule is dependent on the whole compound as such, to what it is binding. So basically you can notice that the oxidation number of one particular atom in different compounds can change and take different values. Calculating oxidation numbers is important because once we get to know the oxidation numbers of an atom in a substance, it helps us to know if that is ready to lose an electron, gain an electron, and so on. Based on this, again, we have one more definition for reduction and oxidation, and we will define them based on the oxidation numbers in our next session. See you all there. Thank you.